Electricity powers our homes, schools, and devices, but it is not always safe. I am Anil. Let's HSE Physics video. In this video, I wish to share the dangers of electricity and how to protect themselves for them. Electricity can cause shocks, burns, and fires if not handled properly. Understanding electrical safety helps prevent accidents at home and in the lab. This knowledge is essential for anyone to working with any electrical appliances or circuit. Normally, first preference is you choose the electrical cable using the different thickness or different gauges of electrical cables is crucial for several reasons related to the safety, efficiency, and performance in electrical system. Depends upon the load, depends upon the current passing through in the circuit, the cable thickness, cable gauges, it will change. Low current, a small gauges cable can use. Otherwise, a high current using is you need a big thick cable, right? Thinner cables carry less current. If overloaded, what will happen? If they can overheat, it melts insulation or causes fires. Different appliances and systems require different amount of current. Example, a refrigerator needs a thicker cable than a lamp because it draws more power. So in a refrigerator, we need a big cable. It's a strong cable because it's a current flowing in that current need to the circuit is high compared to a lamp. Lamp is a small current, so you can use a small cable. So first preference in the electrical safety in our home, we choose the cable. Exact cable we must need to use depends upon the load, depends upon the machineries, depends upon the current flowing in that circuit. If you are not choosing the exact cable, what will happen? Over current flowing in that circuit and it chances to fire. Using the right cable gauge ensures devices receive stable voltage and current, improving their performance and lifespan. See in this cable, more current passing through this circuit. What will happen? The cable overheat. The result is slowly it start to fire. That fire is leads to all other cables in that area is fired. Finally, it's a short circuit and system finally it's totally damaged. This could cause the insulation is melt. Overcurrent passing through the cable, heat produce the leads to melting the insulation. Second very important point is damp or wet conditions. Increases the risk of electrical shock because water is a good conductor of electricity. Dry skin has high electrical resistance which helps protect the body. That's why if you are in the wet condition, the resistance is very low. So it current passing through the wet water conduct is very fastly, more fastly compared to dry. So that's why if wet condition, we get easy to electric shock. When the skin is wet, its resistance drops dramatically, allowing more current to flow through the body. So very important points. That's why we never keep any water condensed material, water bottle or any something is near the electrical cable or near the electrical socket something area. So main key points is water is the high conductor of the electricity. That's why if it condition, if you are touching the plug also a little bit covered the wet condition, so high current passing to our body. So chances to electrocution. Another important point is load. Load means a circuit, a power box has a capacity. We connect overload, more plugs connecting, what will happen? It consume the overcurrent. There are many types of electrical sockets used around the world, each designed to match regional standards for voltage, current, and plug shape. Here, can you see this picture? The socket is designed only for 4 plug, but here connecting around 7 plug. What will happen? More current flowing in that specific point. It cannot load, it consumes, its strength is not enough to carry that current. Finally, what will happen? That point will heat and will chances to fire. So always remember, our socket is our electrical main circuit is designed earth, neutral, and live wire. Live wire is only passing the electrical current. Live wire is mainly used for passing through the electrical current. What is the purpose of neutral? Neutral is for connectivity to the live wire. Then only circuit complete. If you need to work any electrical equipment, you just need only neutral and live wire. No need earth. Earth is only used for the safety precautions. Only for the safety precautions. So neutral, a main electrical circuit consists neutral, live, and earth. Thank you for watching. I will continue this video to our next program.